Hello guys, welcome back to my SAP2000 tutorial class. In this tutorial class, we are going to discuss about the loading part. First, we are going to know what is load pattern, load cases and load combination. After that, we are going to know how to apply load on any kind of model in SAP2000 software. And finally, we are going to analyze a 2D frame in SAP2000 software. So if you are new in my channel, please subscribe my channel to get this type of video in future. I have also started many other tutorial series like structural analysis and structural design part by 3D animation. So if you are interested, you can visit my channel to watch this type of video. So now moving on to the topic. A load pattern is a specified spatial distribution of forces, displacements, temperatures, and other effects that act upon the structure. Each load pattern may consist of an arbitrary combination of the available load types like joint forces and moments, element forces and moment, displacement forces, forces on area element and solid element, etc. So in simple word we can say load pattern basically define the loads type, but it doesn't define the loads nature. So that's why a load pattern by itself does not cause any response of the structure. In order to get the response in the structure, we must apply it load pattern in load cases. A load case defines how the load patterns are to be applied. That's mean the load we are applying, that is statically or dynamically, or how the structure responds, like the structure will behave like linearly or non-linearly, and how the analysis is to be performed. That's mean modally or by direct integration. So all these parameter we have to define in load case. A load case may apply a single load pattern or a combination of load patterns. The result of load cases can be combined after analysis by defining load combinations, also called combos. A load combination is a sum or envelope of the results from different load cases. Let's see how can we add different type of loads on model. I'm going to proceed with creating this 2D frame model and applying this type of various load on it. These loads can be classified into three categories, namely dead load, live load and seismic load. In dead load category, I am going to include the uniformly distributed load and uniformly varying load, while in live load category, I am going to include concentrated load and moment. Lastly, I am going to include the lateral load in seismic load category. Now let's proceed with creating the model. To start a new model, click on File, then click on New Model. In this window, here default units is set to kilonewton meter centigrade. I'm not going to change this, and default materials, here it is India. So I'm also not going to change this. So if you use older SAP2000 version, there you may not see this option, but in newer version it is available. So here I'm going to select 2D frame template, since we are going to model a 2D frame. So click on this. Here I'm going to keep the 2D frame type as portal, since we don't have any basing system in this model. And now in portal frame dimension, I'm going to click on this use custom grid spacing checkbox, because our model doesn't have equal story height and equal bay width. If your model have equal story height and bay width, you can put the story number and story height and also base number and base width. But in our case, our model doesn't have equal story height and bay width, so that's why I'm going to click on this edit grid. In this window, I'm going to click on this quick start, and here we are going to provide number of grid lines along x direction and z direction only, since we are going to model a 2D frame which is in xz plane. So in our model, the number of story is 4, so that's why along z direction number of grid line will be 5, so we don't need to change this value. But number of base is 2, so that's why in x direction number of grid line will be 3, and number of grid line along y direction will be only 1. And now the grid spacing will be along x direction. I'm putting it 3.5 by default. It is in meter unit, and along z direction I am putting it 3. But along y direction it is not required. If I also provide any value here, it doesn't matter. Now I'm going to click on OK, and now here the grid line is added. Now I'm going to click on this spacing, and now along x direction the spacing is 3.5 and 3.5. But in our model the first spacing is 4.5, so that's why I'm going to change this to 4.5 meter, and along z direction the first spacing will be 3.2, then 3, then 4, then 3. So that's why, so first spacing will be here 3.2, then this will be 3 meter, this will be 4 meter, and again this will be 3 meter. So now it's ready. Now I'm going to click on OK. In this section properties portion, we have to define the frame section properties. By default, here default section is selected for beam and column member. Suppose in our 2D model, we are going to provide rectangular concrete section as a beam and column member. To add rectangular concrete section, you have to click on this add button, then click on add new property. Here select the type of section. Here it is concrete section, so select concrete from this drop down, and then click on this rectangular section, and here you have to give the name of the section. Suppose this is beam section, I am naming it as a beam, and depth of the beam suppose 0.4 meter. Here the unit is in meter unit, and suppose width of the section is 0.25 meter. And now here you have to select the material properties. By default here M30 material is selected, because at the beginning of the template we have selected the default material Indian, so that's why this M30 material is automatically created and selected here. If you want to add different grade of concrete, you can click on this add button and you can add the different material here. And now here I'm going to click on this concrete reinforcement, and here you have to choose the river material. By default it is HYST 415 grade of steel is selected, so I'm not going to change this. This is for longitudinal bar and this is for confinement bar. In design type I'm going to select beam here, since it is a beam member, and here you have to provide the cover of the river for top reinforcement and bottom reinforcement. Now say assume here we are considering the concrete cover from the center of the river for top and bottom reinforcement is 60 mm. So it is totally depend on the bar diameter and also stirrup diameter. So depending on that you can calculate what will be the actual concrete cover for longitudinal top river and bottom river. So here I am just assuming 60 mm for top and bottom bar, and this portion is for ductile detailing. So if you want to provide ductile ductile detailing data here, you can add it here. Now I'm going to click on OK, and now I'm going to click on OK on this window, and now here the beam section is added. Now we have to add section properties for column member. So again, click on this add new property, and here select the rectangular section here, and here give the name of the section. Say I am giving name here column, and here you have to provide the dimension. Say I am considering here square section. Say the dimension of the column is 0.25 meter by 0.25 meter. All here we are going to use same material for column member also, that is M30. And here now click on concrete reinforcement, and here the rebar material is already selected as a HOSD bar, and now in design type it should be column PM to M3 design, and here I am considering rectangular section, so that's why reinforcement configuration will be rectangular, and here confinement bars we are providing tries here. And now here you can provide any preliminary data for longitudinal bars, like you can provide clear cover. So here I am considering the clear cover is here 40 mm, and also the number of bar you can provide here. So by default here I am going to provide along direction 2 and 3, number of bar is 2. Now here I am considering the bar diameter is 16 mm, so that's why I'm going to select 16D here. And for confinement bar I am assuming the bar diameter is 8 mm, and here also one tie is sufficient, so that's why in direction 3 it will be 2, and also in direction 2 it will be 2, and the spacing for confinement bar I'm assuming here 150. And here I'm going to select is reinforcement to be designed, and now I'm going to click on OK. So already I have made another tutorial where I have clearly described all this detailing, so you can watch this video for any clarification. Now I'm going to click on OK, and now again I'm going to click on OK, and now the column section is added. Now I'm going to click on OK, and now here I'm going to select for beam material, it is beam, it is selected, and for column material I'm going to select it column, and now I'm going to click on OK. Now here you can see the portal frame is created. Now I'm going to check whether all the spacing is correct or not, so that's why just I'm going to click on right click on this node, like here. If you go to in this location tab, here you can see the coordinate. So here the coordinate is 13.2, and also check here what is the coordinate. Here the coordinate is 3.2, so first spacing was 3.2, and second spacing was 3, so that's why it is 6.2, and the third spacing was 4, so that's why it will be 10.2, and last one was 3, so that's why it should be 13.2. So here all the spacing is correct for beam member, and also for column member check it. Here the x direction spacing is 4.5, and for this next one is 3.5, so that's why it's coming 8. So here all the spacing is correct. Since we have used 2D frame template, that's why the beam and column member is automatically added along with the grid line, and also the section properties is automatically assigned to the corresponding member. So here you can check that this is beam member. For beam member, just right click here and go to in these assignment tabs and check here the section properties is beam. And also for column member, you can check whether it is column section is added or not. Here you can see the column section properties is added here. So like this, for each member the section properties is automatically assigned here. Now we are going to provide the support here. In our model you can see here fixed support is provided at base. So now I'm going to provide it fixed support here. So first select the nodes here. So here I am going to select node number 1, 6 and 11 here, and now I'm going to click on assign, then click on joint, then click on restrain. So here we have to provide fixed support. You can click on this fixed support symbol. So if you click on it, so the restraint will be applied in all three translation direction and also in all three rotation direction. Since it is a 2D model, either you can restrain in all direction, or since it is a 2D model, the restraint can be applied only in X direction, in Z direction for translation movement, and for rotation movement you can provide restraint along Y axis. So here you have to provide restraint about local axis. So as you know that the local axis direction is same as global axis for node, so that's why here I'm going to select translation 1 and translation 3, and I'm going to uncheck this translation 2, and I'm going to provide restraint along rotation 2 only, and I'm going to uncheck this rotation 1 about 1 and rotation about 3. Then I'm going to click on OK. So if you do this, it's mean this is applicable only for 2D frame. It is not applicable for 3D frame. So if you do this, you must set the analysis option. You have to consider only it is as a plane frame member. It's mean the degree of freedom will be applicable only X direction, Z direction and rotation along Y direction. Otherwise you will get error on the stability of the structure. So now I'm going to click on OK here. Now our model is ready for applying the loads. Since we have divided our loads in three categories, so that's why we have to define three different load pattern. So to define load pattern, you have to click on define, then you have to go to on load pattern. And now by default here you can see the dead load pattern is added with a self weight multiplier 1. It's mean the self weight of the member is added in this load pattern. So if you modify this self weight multiply with 0, it's mean the self weight of the member will not be included with it. So now another load pattern we have to define, that is for live load. And now here we are going to choose the type as live load, and here the self weight multipliers would be 0. Now I'm going to click on add new load pattern, and another load pattern I'm going to add, that is seismic load, and I'm going to select here type of pattern is quick, and here auto load pattern option I will select none, because I'm not applying this seismic load as per any code. So some lateral load value is there, so just I'm applying those loads in seismic load pattern cases and nothing else. So that's why I'm going to select here none. Now I'm going to click on this add new load pattern. So now the load pattern is added. Now I'm going to click on OK. So now the load pattern have added. In load pattern we had to define type of loads. So this type of load will be used when we will use the automatic load combination command. Suppose here in load pattern we can write anything, but in load type what we are defining, that is matter. Suppose in load pattern I am writing live load, but in load type I am defining it as a dead load. So software when will use the auto load combination command, that time software will consider this live load pattern name as a dead load, because I have defined that load pattern as a dead load. So that's why this type of load is very important when you are going to use the automatic load combination command. So be careful with that. So if you make any mistake in the type of load, then your load combination will not come correctly. So now I'm also going to show you one thing. Here you can see under the load cases these load cases automatically created. So when I have defined these two different load pattern like live load and seismic load, so these load cases automatically created, and by default here dead and modal load cases was there, so I haven't created anything here. So these are the by default load cases. It will be automatically created when the model will be initialized. These are the load cases which have created after the creating the load pattern. So here all the load case type you can see the linear static, so we don't need to modify anything here because we are going to perform a linear static analysis. So that's why here you can see the load case type is static and the analysis type will be linear, so we don't need to modify anything here. So just we are going to click on this OK. Now I'm going to add these loads corresponding load pattern. So under the dead load category I'm going to add this UVL and UDL load. So here you can see this UDL, the UVL load is in this member and UDL load is in this member and in this member. So what I'm going to do, so first I'm going to select the member, this member. So in this member I'm going to add the UVL load. So just select this member, then click on assign, then click on frame loads. Under this frame loads, here you can see there are different type of load. So here I'm going to select this distributed load, and now one window will open. Here you have to select the load pattern. So I'm going to add the loads under dead load pattern, so that's why I'm going to select here dead. And now here you have to select the coordinate system. So you are going to use which coordinate system, that is global or local. So here since the load is in downward direction and also the member is parallel to the global axis, so that's why here I'm going to select the coordinate system global. In some cases you may select the local coordinate, so it's totally depend on the member orientation. And now the load direction, here it should be gravity mean it should be in downward direction. And here the load type, so here I'm going to apply the forces, so that's why here in load type I am going to select force. And now here in this option you have to select you want to add to existing loads or replace existing loads or delete existing loads. So since I haven't add any load in this member under dead load pattern, so that's why you can select any one option from here, that doesn't matter actually. So by default it is replace existing loads, so I'm just keeping this replace existing loads here. And in uniform load, if the load is UDL you can write the magnitude here, but in our case it is a triangular load, so that's why we are going to put the loads value in trapezoidal section. So here you can see the first this distance is the relative distance, so you can change that. Here it is relative distance and here it is absolute distance. So actually relative distance mean the whatever length this member have, it will be considered as a 1 unit, and corresponding relative distance you can calculate. Suppose the member length is say 4 meter, and you want to add a loads intensity suppose at 2 meter, so it's mean the if I consider the 4 meter length as a 1 unit, then 2 meter should be 0.5. Like that you can calculate the relative distance and you can put the intensity, load intensity value corresponding relative distance value. But maybe it can useful for some cases, but in other cases it may not be useful, so that time you can use the absolute distance. So in our cases we have to assign this UVL load on this member. So here you can see at this node the load magnitude is 20 kilonewton per meter and here the load magnitude is 0. So I'm going to use the relative distance, and this relative distance is starting from end I. end I is the start point in SAP 2000 software. So first of all, you have to know which point is the start point and which point is the end point. To know that, you have to click on this display element assign, then click on frame, then you have to click on this local axis, and then click on this OK. And then here you can see the direction of the local axis. So it's mean, so this node is the start node and this node is the end node. So now, since this is the start node, so here the relative distance will be 0 and the load magnitude will be 20. So now I'm writing here 20, and now the next relative distance will be 1 here, so right here 1, and here the load value will be obviously 0. And now rest of this field you should put 0 here. Now click on this apply, and now click on this OK. So now here you can see a triangular load is added in this member. Now I'm going to assign UTL load on this member and in this member. So first I'm going to select these two members, these members and these members. Now click on this assign, then again go to the frame loads, then select distributed, and here the load pattern should be dead load, since I want to add this UDL load under dead load pattern. And here this value should be anything, it doesn't matter actually. And now here I have to put this 0 because I don't want to add any trapezoidal loads. Here I'm going to add the UDL load, so that's why I write here 20 kilonewton, and here the others load direction will be gravity, and also the coordinate system should be global. And now I'm going to click on this apply, and then I'm going to click on, and then here you can see the UDL load is added here. So this is under dead load pattern. Now I'm going to assign loads under live load pattern. As per model, we have to assign a anti-clockwise moment at this node. So that's why first I'm going to select this node, then click on assign, then click on joint loads. Since we have to apply this load on joint, so that's why we are going to select this joint loads command, and under this you have to select forces, and here you have to select load pattern as a live load, and here you can see we can apply forces along 3 global axes, and also we can apply moment along 3 global axes. Or you can change this, if you want to apply these forces or moment along local axis, you can do also same. So here I'm going to apply the moment about global axis. So as per our model, we have to apply this moment along y axis, so that's why I have to write the moment value here, that is 20. And now here the moment is anti-clockwise. So if the moment is anti-clockwise, then the direction of the moment will be along negative y, so that's why it will be minus 20. And now I'm going to click on this apply, and now I'm going to click on this OK. So here you can see that this live load is added, 20 kilonewton moment is added here. So if you see the 3D view, you can see the direction of the moment. Here you can see the direction of the moment along negative y direction. It's mean here the moment is applied along anti-clockwise direction. Now I'm going to add this concentrated load and this moment. I'm going to see the XZ plane view here, and now here I'm going to first select the member. Since this load we are applying within the member, that's why we have to assign this load on member. So now I'm going to select this member, and now I'm going to click on this assign. Then I will go for frame loads, and then I will click on this point, and here I have to select the load pattern. It should be live load. And now here I have to write the point loads value, and here the distance value is given. So here I'm going to use the absolute distance, because here the distance is given, that is 2 meter. And now here absolute distance here 2 meter, and the load magnitude is here 30 kilonewton. So I'm writing here 30 kilonewton, and rest of this field will be 0. And now I'm going to click on this apply, and now I'm going to click on OK. And here you can see a concentrated load is applied here, and here you can see this is the 3D view. A 30 kilonewton load is acting in downward direction at a 2 meter distance. Similarly, we have to apply another moment in this member. So that's why I'm going to select this member, and now I'm going to click on assign, then frame loads. Under this frame loads, I'm going to select point, and here this load type should be moment, and here I will write the moment value. And here you can see this moment is in clockwise direction. It's mean it is along positive y direction. So here I'm going to select y direction, and here the magnitude will be 20. As you can see, the load magnitude is 20 kilonewton meter, and here the unit is here kilonewton meter. So now I'm going to apply here, and now here you can see the load is applied. In 3D view you can see the load is applied along positive y direction. So now all the loads under live load pattern I have applied in this member. Now I'm going to apply the seismic loads here, I mean the lateral load. So as per model, here you can see the loads are applied in these joints. So now I'm going to select first this joint, and now I'm going to click on again assign, then it should be joint load, then forces, and here the load pattern should be seismic load, and here the coordinate should be global, and here this load we are applying along positive x direction. So here the magnitude is 27 kilonewton. So here I'm going to write 27, and now I'm going to click on apply, and now again I'm going to select this node, and now here the magnitude is 22 kilonewton, and here I have made one mistake. As you can see, in this node also this moment is applied, right? So be careful with that. When you are selecting some nodes and applying some moment, be sure that only one field is filled. Otherwise what will happen, here in this node actually two load is applied. One is this 27 kilonewton lateral load, and also this moment. So that's why what I'm going to do, I'm going to set this 0, and here I'm going to select this replace existing load, and now I'm going to assign again, and here now only this one load 27 kilonewton load is applied. Similarly, I'm going to select this node, and now I'm going to apply this 22 kilonewton load. So now I'm going to write here 22 kilonewton, and now I'm going to click on this apply, and now again I'm going to select this node, and here the load value is 15 kilonewton. So now I'm writing here 15 kilonewton, and now apply. Similarly, here 10 kilonewton load is there, So I'm going to apply 10 kilonewton load here. And now all the seismic load I have applied here. Now our model is ready for analysis, and now I'm going to click on this analysis and run analysis. Here I'm going to run all the load cases, so select all load cases, and or you can click on this run, and now click on this run now, and here you can see the analysis is started. And here you can see the analysis has been done. And if you want to see the result, I mean, suppose if you want to see the bending moment diagram or displacement data, so all of these thing you can get from this table. So just click on this display, then show table, and here which type of data you want. Like suppose I want joint output like displacement, and now here select the load cases. You can select all the load cases and then click on OK, and click on OK. So in table format you will get the all the joint displacement value here. So like that you can bring multiple number of tables here. Or suppose if you want frame output like frame forces, also you can bring them here. And also you can export these tables in Excel like this, export all table to Excels like this. And also if you want to see the bending moment diagram, here you can see that, like here frame stresses like moment about 3 axis, and here you can see the bending moment diagram under dead load. This is under modal load, this is under live load, here it is, this is under seismic load. So, and also if you want to see the shear force diagram, you can get that. So shear should be local axis too. So here the all the result you are getting about local axis. So be careful when you are selecting this component value. So like that you can get the, also if you see, if you click on this show value, you will see the value also here. So like that you can get any kind of, I mean, like that you can get the shear force and bending moment diagram of this frame. So if this video help you, please like my video and share this video to your friends, and also subscribe my channel. Thank you.